Hello friends, this is Durga again from IT Varsity. As part of CCA Spark and Hadoop developer, at this time we are talking about calculating aggregate statistics using Spark. We have covered the total aggregations like average, sum as well as max on the total data set, and then we also covered all the different by key aggregation functions like count by key, group by key, reduce by key, aggregate by key, as well as combine by key. So as part of the previous video, I just demonstrated how we can get a count of orders, total orders by order status, um, and we have implemented using all the by key operations. And in this video, we will try to develop more advanced aggregation functions, and I will also emphasize how you can actually determine which aggregation function should be used in those scenarios. So first I will try to get total revenue per day, and if you recollect from the join video, order items have the order item subtotal. So for each order there is the order item, there are multiple order items, and for each order item there is a subtotal, and we have to use that amount to compute the total revenue. And also we want to get total revenue per day. So as we need the date to compute per day, that date is available in orders, so we have to join these two data sets. So these 5 statements I have already covered as part of the join videos. So in this case I will just copy paste into our Pyspark console, and then we will see what needs to be done to get the total revenue per day. And also when you launch Pyspark, make sure you give the absolute path to the 1.2.1 version, so that it won't launch with 1.3.0, as 1.2.1 is part of the certification syllabus. I have set up 1.2.1 on the existing Cloudera VM, and I am running Pyspark using 1.2.1. Now it has launched Pyspark with 1.2.1, which is nothing but Python command line interface. Now copy paste these 5 statements and paste it. Now the data is joined, and you can see the data set by running this command. Copy paste dot take 10 print of 5, and it will give the 10 records after the join. And you can see that this is a tuple, a key value tuple, and key is the order ID, and the tuple has 2 elements. It's one is the order ID as key, and the value itself is another tuple, in which the first element is the entry from order items, and the second element is entry from orders. And you can get order date from the second element of the tuple's value, and you can get the order item subtotal from the fifth element of the the main tuples, of the tuple's first value. So we have to get these 2 things. This has to be the key, and this has to be the value, so that we can actually perform the sum. To get these 2 things, you need to run the map function like this, and you can see that first we are getting the order date. Order date is represented by, this is t of 0, this whole element is t of 1, and then this one is t1 of 0, this one is t1 of 1, and we are applying split on that using comma as delimited, and this one is the order date. So t1 1 dot split by comma of 1 will give the order date. Similarly, T1, which is this one, of 0, which is this one, split by comma as delimiter, and then the fifth element, which is represented by number 4 in the array, will give the order item subtotal, and as it is of float type, we have to typecast it. That's what is happening here. So you can copy paste this command, and now you got the order date as key, and for each and also we have extracted order item subtotal for each order item as value. So you can actually do for I in. So for any reason, if it throws error, you need to validate whether each statement is correctly working or not by using this for loop. Because it uses lazy evaluation, most of the commands might pass, but when you try to run, it will throw the error, and the error can be misleading or confusing. For that reason, if there is any error, make sure you run the script like this to evaluate immediately at each level and see the results whether it is working or not. Collect, print of I. Now you can see the first element of the map output is the order date, and the second element is the order item subtotal for each of the order item in the data set. And now we just need to get the revenue per day. So by holding this as key, we have to use the aggregation function to get the order item subtotal for each day. And now we will see which function should be used. Shall we use groupByKey? Shall we use reduceByKey? Shall we use combine_by_key or aggregate_by_key? We should not use groupByKey, even though it gives the exact same results. And the reason is groupByKey does not use combiner, and hence we have to choose one of reduceByKey or aggregateByKey or combine_by_key. So sum, it's a plain sum. In this case, our input data type for the reduceByKey for the value is float, and also the output data type after the aggregation by key is also float. So the data types are matching, and also the combiner logic and the reducer logic is same for sum, which means that if you want to add let's say 1 to 10 values, 1 2 3 4 5 6 7 8 9 10, whether you add each element or if you divide data into two subsets, 1 to 5 and 6 to 10, and then add those intermediate values, in both the ways the results will be the same. So as the input and output data types are same, and also the combiner and the reducer logic are same, we can directly use the reduceByKey, and it's pretty straightforward. You just copy paste this function where we are getting accumulator and value, and we are adding values to the accumulator moving forward, and accumulator will hold the result for each key and the total revenue for each key. Hence we can actually copy paste this, and then we can do for I in revenue per day dot sort by key dot collect. In this case, as I am using sort by key, it uses the order date, and then you can do print of I and hit enter. It will fetch the results in a moment, and you can see that it's the for July 24th, the order item subtotal is 97,076. So this is how you can actually implement more complex aggregations. First you need to determine how you want to get the final result and the relationship between the aggregate function input and the output types, and then you can actually use one of the reduceByKey or combine_by_key or aggregateByKey to get the final result. Now we will write one more complex aggregate function. We will try to get average revenue per day when we actually did the joins, we joined orders and order items, and then we got the total revenue from order items, and also we got the count of distinct orders. We ran that as part of the join, and we will take it to the next level. Now we will try to compute the average using that result set. And when we actually use the joins in the past, we have joined twice. First time, orders and order items to fetch to relate the order date and the total revenue per day, and then another and then we have ran one more process wherein we get distinct orders for each order date, and then we have joined second time to get the final result of order date, total revenue per day, and total number of orders per day. And in that case, we have used reduceByKey. We can actually use combine_by_key or aggregate_by_key, and we can eliminate one join completely, and I will demonstrate that as well as part of this video. If you want to understand what we have done at the time of join, you can go back and see my join videos. Now this is what we are trying to do. We want to compute average revenue per day. That is our problem statement. For that, first we need to pass the orders. The key will be order ID. Pass order items. The key will be order item order ID, which is nothing but the child table, 2 orders, and this is the foreign key. This column has the foreign key to order ID of orders. So we have to pass these two things based upon orders with order ID and order items with order item order ID. And then we can join the data sets, and then we will get the joined data set with the order ID as key, and the value will be a tuple. The first element could be order items and the second element could be orders, each and the record from order items and the corresponding record from orders. And then we have to pass the joined data set again to use order date and order ID as key and order item subtotal as value. The reason why we need to use order date and order ID as key is that we once you have this as key, for each unique combination you can assign one to get the distinct orders. So that's where we have to use these things. I will demonstrate when running the script, but these are the steps. We need to pass the join dataset and get order date and order ID as key and order item subtotal as value. And then we have to use appropriate aggregate function, in this case reduceByKey, to get sum of order item subtotal. So in this case, you will not get the revenue per order date. It will be per order date and per order. So there can be multiple entries for an order in an order items. In this case, we are grouping the subtotal to order itself. So if you have 57,000 orders and if you have 172,000 order items, this will retrieve 57,000 orders with the corresponding order item subtotal. And then you have to discard the order ID by passing the result set from the key and get the order date alone, and get the sum of order item subtotal per order as value. So once you get the order item subtotal for each order, so in this case also order date will have multiple entries of order item subtotal at each order level. We are just discarding the order ID. We will get all the order dates and all the order item subtotals as key values. Once we have that, we can compute the sum of order item subtotal holding order date as key by applying another aggregate function, and also we can actually get the count of distinct order IDs also. So, and then we have to finally pass the data and apply average logic. That's the flow. So I will not explain until this. This is plain join. We have actually got the orders using order ID as key and order items using the order item order ID as key, and then we are joining these two data sets. It's pretty straightforward. First we are reading the data, then we are passing, then we are actually joining the data. And then if you see orders, join order items dot take 100 print of I and hit enter, you can see you have the order ID first, and then order items record, the corresponding record from the order items, and then the corresponding record from the orders table here. So it's a joint data set. From here we have to get the order date and the order ID as the keys, and then the order item subtotal, which is this element, as the value. So this one will give that. In this case the key will be a tuple and the value is will be the order item subtotal. The tuple will contain order date and order ID. I am pasting it here, and then I am printing it for I in, copy, paste, dot take of 100 print of I and hit enter. You can see now the first element in the tuple, which is key, is a composite one. It has order date as well as the order ID, and then the second element in the tuple is the order item subtotal for each order item. And now we have to apply the aggregate function. It's to get the order item subtotal for each unique combination of order date and order ID. So it's a plain addition, and here the input type for our reduce function or aggregate function, and the output type for our aggregate function is float. So we can directly use the reduce by key here like this, which we have already seen in the past, and paste. Now you can actually evaluate by running this one, copy, paste, dot take 100 print of I and hit enter. And you can see now you have only there are no duplicates for order date and order ID. It's a unique combination, but the value is added. So you got the revenue for each order date and order ID. Now we can use this information and to get the total revenue per day as well as distinct orders. We just have to count for these items for each day, and then we have to get the sum of the revenue, which will give the total number of orders for a given day as well as the total revenue per day. So for that we have to discard the order ID, we have to fetch the order date, and then we have to sum these things, and also we have to add all the records for a given date as part of this. So in this case the input is a float variable, but the output is a tuple, which is a float which contains two items. One is the total sum, and the second one is distinct orders. So we cannot use reduce by key here. So either we have to use aggregate by key or combine by key, and the script for aggregate by key and combine by key looks like this. So first we have to map the results to discard the order ID and get the order date from here, and then order item subtotal. Now if you see the results, let me first do the count on this. Copy, paste, dot count and hit enter. You can see there are 57,431 records, and then run this statement and also do copy, paste, dot count. It will also return 57,431 records, and then you can also print the results, dot take 100 print of I and hit enter. So here you can see that we got the order date, all the order dates for all 57,431 records, and then we got the order item subtotal for each order and order date. So now we have to do the sum of these things and also get the count of these things. So after the aggregation, the output will be a tuple for the value. The key will be the order date itself. So we have to use either the aggregate by key or combine by key, and the logic looks like this. You can either use combine by key or aggregate by key. It's your choice. Both work almost the similar manner. I will explain, and also the except this one, rest of the stuff is same. So as while the initialization or as part of the aggregate by key, or the declaration as part of combine by key, you have to create a tuple. In this case, I am initializing both the values in the tuple to zeros. Here I am getting the tuple with the x itself, which is similar to our map function, and in this case the x will be the output of the previous step, which is the order item subtotal. So this is order item subtotal, and this is 1 for each order. And then in next step is same in both the cases. We have the accumulator and we have the revenue. As we have two items that needs to be returned, the accumulator will have the accumulator is a tuple. That's why we have to provide the array subscript for the accumulator, and as part of this, the first one is accumulator, which is a tuple, and the revenue is nothing but this element. So this is the revenue. So we have for the first element in the accumulator tuple, first we are adding revenue moving forward, and as part of the second element in the accumulator tuple, we are just adding once for each iteration. So in this case, you can actually add it like this, and then in the final step, we are actually adding the intermediate values, which is pretty straightforward. In both the cases, it's the same thing. In this case, both accumulator as well as the value as part of our lambda function are tuples. So we have to subscript like this in both the cases. So we have to add first element of these two tuples to get the revenue, and the second element of the tuples to get the count. So you can run either of the function to get revenue per day per order, and you can validate by running this command. Paste it and enter. Now it works. Now you can see that revenue per day per order count will return only 364, and you can also validate the results. For I in revenue per day per order dot sort by key dot collect print of I, and hit enter, and you can see that you got the order date, the orders, the revenue for that day, and the total number of orders for that day. To get the average, we just have to divide the total revenue with the total number of orders for each day. And if you see the results here, and the results of our join function, which we ran as part of the earlier videos to get these things, are same. They are exactly the same. So either you can use two reduce by functions and two joins to get the results, and one join, one reduce, and then one aggregate or combine by key, which eliminates one join completely. And to understand which one is better, you have to run on larger data set, and based upon the time and other statistics, you can determine which one is running better. But I'm assuming that the second one, which we have written now, will perform better because we are joining only once, and then we are using one reduce by and one aggregate by versus two joins one and two reduce by key functions. But that's just an assumption. Don't take my word that this second approach will run faster. Unless we get into the execution metrics, we cannot confirm which one is better. That being said, now let's compute the key, average. For that, again, we have to write the map function to actually divide this value with this value, and you can do that by saying average revenue per day equal to revenue per day per order dot map lambda rec, and then we have to get rec of 0 divided by rec of 1, and then hit enter. And now you can do average revenue per day dot count. It will return 364 records. Yeah, so the problem is here, if you see here, this is 0 element, this is this one is first, and then out of this one I have to divide the first element of the value with the second element of the value. Now for that we have to write function like this. The key is the order date itself, so the map function is returning the tuple again, and with order date being the key, and then x1 of 0 which gives the revenue, and x1 of 1 which gives the total number of orders for that day. So we can use this map function directly, paste it. Okay, I think I have changed the so I have to use this one. Okay, now I'm running this one. Paste it. Now you can do copy, paste dot count. It returns 365, and for I in, paste dot sort by key dot collect print of I, and hit enter. And now you can get the average average revenue for each day from our data set. It involves the joining, it involves the reduce by key aggregation, and also it involves the either aggregate by key or combine by key aggregation to get the final results. It is very important to understand this one. This is pretty complicated, and also it achieves quite a bit of stuff in this 20 odd lines script. Make sure you understand each and every step in detail. Make sure you run each and every step individually, and then run the for I in script to see the results and understand the structure of the data, which can help you in writing better scripts going forward. That being said, I hope you are enjoying the content on my channel. If you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. If you want to ask any technical questions, please use Stack Overflow with appropriate tags such as Pyspark and Apache Spark. If you want to discuss either about Spark or certifications, please join my groups, ITversity Apache Spark or ITversity Hadoop Certifications. And if you are not subscribed to my channel yet, please do so. You will get to see a lot more content like this. That being said, as part of the next video, We will do the max operation also by key, and then we will wrap up the aggregations as well. Thank you. Bye.